Good evening to everyone and welcome to today's wonderful evening with Dr. Murali Bharadwaj. Every day we all meet and at least 1 hour we will try to spend together. Whenever time is there, we will try to spend a little longer. And we finished 22,000 PYQs in the next 6 months and get ready ourselves for the upcoming NEETPG and also for the INICET. Very nice to see 9 online classmates. Can you please punch as a voice loud and clear? So today I picked up a new format of the live broadcast. 1 minute. Yeah. So, hi, sir. You are audible. Thank you very much, Saravana Kumar, and many more who are all online. Please share in all your WhatsApp study groups the YouTube link, and at the end of the session, like it and share the YouTube. There is more happiness and fun in sharing the knowledge to the others. So let's make the great beginning, Doctor. Severe combined immunodeficiency typically is caused by adenosine deaminase deficiency is what you have to remember. So where do you get this ADA? So here you have the deoxyadenosine, which will become deoxyinosine, which in turn will go into purine salvage. And it is also degraded into uric acid. So for the conversion of this deoxyadenosine to deoxyinosine, you require ADA, and any ADA deficiency will cause the deoxyadenosine triphosphate to get accumulated. All the deoxyadenosine unable to convert into deoxyinosine will convert into deoxy-triphosphate, adenosine triphosphate, which is responsible for the lymphotoxicity and the immunocompromised state. In severe combined immunodeficiency is what you have to basically remember. Hyperuricemia, self-mutilation, intellectual disability. Where do we see, doctor? Lesch-Nyhan syndrome, which is due to hypoxanthine guanosine phosphoribosyl transferase deficiency, the Lesch-Nyhan syndrome. So this is how, doctor, you can see the self-mutilation, which is one of the very important feature in case of Lesch-Nyhan syndrome, is what you have to basically remember. Nice to see Gajendra Gaud and many more who are all online. Wonderful, doctor. Keep punching your thoughts whenever you are listening to the class. That is the best way that you can engage yourself and be happy, learn, revise, active recall, spaced repetition, along with the teacher as your classmate, roommate, benchmate, tablemate in everyday class, doctor. So now, xeroderma pigmentosa, it is because of the defect in the nucleotide excision repair. So typically, whenever ultraviolet rays happen to fall, there will be formation of the pyrimidine dimers. And these pyrimidine dimers need to be repaired. Otherwise, it leads to a lot of problems in the skin. So the defect in the nucleotide excision repair is responsible for xeroderma pigmentosum. So this is how, doctor, whenever the nucleotide excision repair defect is there, that predisposes to the development of all the clinical manifestations. Whenever the ultraviolet light happen to fall, it will lead to formation of the reactive oxygen species, which lead to the development of the pyrimidine dimers, is what you have to remember. SAM, S-adenosyl methionine, It is considered to be the universal methyl donor. Universal methyl donor. Whenever any biochemical reaction is involving methyl group to move from one reactant to another in biochemical reactions, that is the place where SAM, the S-adenosyl methionine, will act as a methyl donor, is what you need to remember. Maple syrup urine disease. What is this? Branched chain keto acid dehydrogenase deficiency. Branched chain keto acid dehydrogenase deficiency. So typically, the leucine is unable to metabolize whenever the branched chain keto acid dehydrogenase is not available. Leucine, valine, isoleucine. So leucine will form acetoacetate and acetyl-CoA. Valine will form propionyl-CoA. Isoleucine will form acetyl-CoA and propionyl-CoA. So for this valine, isoleucine, leucine to get metabolized, you require branched chain keto acid dehydrogenase. Its deficiency lead to maple syrup urine disease is what you have to basically remember. In Hartnup's disease, what will happen? Tryptophan is excreted in the urine. The tryptophan is the one which is excreted in the urine. You have to remember, Dr. PYQs are the gold standard. There is nothing else. 22,000 PYQs if you solve along with me, right? You know what examiner wanted. How we got this 22,000 PYQs, doctor? 10,000 PYQs of the NEETPG last 10 years. 6,000 PYQs from INICET exam. 6,000 PYQs from FMGE. So once you solve this 22,000, you automatically know what examiner wants, what you need to remember, what you need to reproduce, last moment, what you need to revise, everything. So I provide this all in the form of single liner like this, which topic it belongs to, so that you'll also know what topics are frequently asked and what aspect of the topic is being asked. And I'll provide this as a notes also to you, all the single liners. These 22,000 single liners, I can courier you the notes. So today only take every opportunity to be part of our 999 rupee program. Just if you pay 999 rupees, you get 1 year support from us, 1 year of 22,000 PYQs revision daily, the cheapest coaching program ever available in the world. In addition to that, you get around 300 hours of complete 19 subjects, 70,000 high yield facts revision, right? So I'm going to be your daily partner in your preparation for the NEETPG, doctor. So whenever tryptophan deficiency is there, that lead to pellagra-like lesions because tryptophan, 5-hydroxytryptamine, right? So this kind of lesions on the skin in Hartnup. Menke's kinky hair disease is because of the copper deficiency. So the dietary copper, once it reaches into the small intestine, typically the high copper will go and deposit everywhere. It will deposit in the kidney, it will deposit typically there will be problem in the brain, the skin, the hair, and also in the bones in Menkes kinky hair syndrome. Once you are eating maize, there is a deficiency of the niacin. So that's the reason diarrhea, dermatitis, dementia is likely in the people who are the maize eaters, is what you need to understand. A female has anemia after subtotal gastrectomy. What is the important role of the stomach, doctor? Intrinsic factor, which is important for vitamin B12 deficiency. So you should know what are the various stages in which the cobalamin is being metabolized in our body. So the cobalamin, once it enters into our stomach, it becomes released because of the peptic digestion. Then it combines with intrinsic factor which is being produced by the gastric parietal cells. This intrinsic factor plus cobalamin will travel into the brush border of the gut. So your pancreas produce the required proteases that will break the intrinsic factor and cobalamin, and that makes the cobalamin to get absorbed across the brush border in the terminal ileum. So in turn, this holotranscobalamin is being used for the DNA synthesis. It has got a very short half-life and a high turnover is what you have to basically remember. So each of these steps, any problem in decreased intake or problem with the intrinsic factor production by the gastric parietal cells, or if there are no peptidases from the pancreas which will make the cobalamin made available to the intrinsic factor, or if there is no ileum ready to absorb the vitamin B12, any of them can lead to the development of the vitamin B12 deficiency is what you have to basically remember. Now, doctor, RBC transketolase, it is the marker of the vitamin B1 deficiency. Vitamin C deficiency lead to collagen not becoming hydroxycollagen, and that lead to development of a easy bruising of the skin and the bleeding gums is what you need to remember. If you remove the ileum is the spot where the vitamin B12 get absorbed. That's the reason vitamin B12 deficiency will happen whenever there is any ileal resection. What is the role of the sunlight in the vitamin D metabolism? Sunlight converts cholecalciferol into 25-hydroxy cholecalciferol whenever there is any vitamin D metabolism. So whenever Wernicke encephalopathy, Korsakoff psychosis, why do you get memory loss, doctor? There are something called mammillary bodies. Mammillary bodies, they get a hemorrhagic necrosis whenever there is a Korsakoff psychosis and Wernicke's encephalopathy because of the vitamin B1 deficiency is what you need to remember. A patient is having macrocytic anemia and a high homocysteine levels, but a normal methylmalonate levels. Very important. Macrocytic anemia can be because of the vitamin B12 deficiency, or it can be because of folate deficiency. Both the folate deficiency, vitamin B12 deficiency can lead to homocysteine levels get elevated. But only vitamin B12 deficiency will cause a high methylmalonate levels, but not folate. That's the reason normal methylmalonate, but a high homocysteine and macrocytic anemia is equal to vitamin B12. Whereas normal methylmalonate with a high homocysteine and macrocytic anemia is equal to folate deficiency is what you need to remember. So this is the point you need to understand. Homocysteine becoming methionine. In the process, methyl tetrahydrofolate become tetrahydrofolate. For that you require vitamin B12. So whether vitamin B12 deficiency is there or folate deficiency is there, either of them can cause homocysteine levels to get elevated and you get hyperhomocysteinemia. But the methionine is the one which will, vitamin B12 is the one which will go and act as a coenzyme. Typically it acts like a coenzyme for methylmalonyl-CoA mutase, which will convert methylmalonyl-CoA into succinyl-CoA, which will enter into citric acid cycle. So that is the reason methylmalonyl-CoA mutase deficiency occur only in vitamin B12 deficiency, and that leads to methylmalonic acid levels elevated only in the vitamin B12 deficiency, but not in folate deficiency, is what you have to remember. Glutathione peroxidase What does it contain, doctor? Selenium as a trace element. Vitamin C deficiency may there is a delayed wound healing, and also vitamin C is necessary for the iron absorption to occur. That's the reason there are low iron levels. What is one Gierke's disease? It is the deficiency of the glucose 6-phosphatase. Where is glucose 6-phosphatase? It is one of the very important enzymes involved, typically in the breakdown of the glucose 6-phosphate into glucose and release the glucose. If it is not there, liver cannot release the glucose, and that lead to development of hypoglycemia. Same time, the high glucose 6-phosphate levels will get directed into the pentose phosphate pathway, leading to excessive pentoses that get metabolized to lead to hyperuricemia. Okay, so hyperuricemia, hypoglycemia, hyperuricemia, hypercholesterolemia, because all that glucose 6-phosphate which is excessive will typically convert into acetyl-CoA, will get converted into increased pyruvate, glucose 6-phosphate, metabolized through glycolysis into pyruvate. Pyruvate become too much acetyl-CoA, and all that acetyl-CoA will contribute to the formation of the cholesterol, leading to the development of hypercholesterolemia. Similarly, all that high pyruvate is converted by lactate dehydrogenase into lactate, leading to hyperlactemia. So, hyperlactemia. And even the pyruvate, if you take pyruvate, is converted into alanine. That's the reason hyperalaninemia. And all that acetyl-CoA can also contribute to the triglycerides, leading to hypertriglyceridemia. So what are all the things that occur in one guy's disease, doctor? Fundamentally, it is the glucose 6-phosphatase deficiency. The moment glucose 6-phosphatase is deficient, glucose 6-phosphate cannot be metabolized. It is increased in its level, and that leads to the development of hypoglycemia, hyperuricemia, hypercholesterolemia, hypertriglyceridemia, hyperalaninemia, hyperlactemia, and growth failure, hepatomegaly, kidneymegaly, nephromegaly. This is what you need to remember about the one guy. Good, doctor. Can you please punch? Is the voice loud and clear for all of you? Please do punch. Did you like this new format? Right? So we try as much as to make a virtual online class into a real class by initiating a conversation with you, by being as close as to you. Right, doctor? So please do come every day. Roz milenge, roz padenge, and we become better every day. Very nice to see Meera. And also please inform all your friends, right, that 999 rupees may 1 year coaching is being given by Dr. Murali Bharadwaj. What do you get in this 999 rupees, doctor? 300 hours of the video already there in the video library that cover almost 70,000 high yield facts from 19 subjects. Also, every day we discuss interactively 22,000 PYQs, which will be made available in the video library for you to do the revision. What more do you need? You have a teacher every day talking to you, every day spending to you, every day inspiring you to consume the content. And ek baar 22,000 PYQs, once you finish revision with me in the form of these facts, then automatically you know what to focus in the tomorrow's exam. So now, doctor, gluconeogenesis, lipolysis, ketone body synthesis, they all get activated by the glucagon. Wherever glucagon is there is a demand on the body to produce more and more and more glucose. That's the reason at early morning, 2 o'clock, glucagon levels increase, and that will lead to hyperglycemia. Similarly, glucagon will lead to lipolysis. It will make the lipid to break down. And it is like glucagon is opposite to insulin. Just like insulin deficiency leads to ketone body synthesis, glucagon presence leads to the development of ketone bodies. So you should know everything about the glucagon, doctor, very clearly. On the brain, it will increase satiety, it will make you eat more food, it will decrease the hepatic glucose output, it causes increased glycogenolysis, increased gluconeogenesis, decreased glycogenesis, glycogen synthesis is decreased, lipid oxidation is increased, lipid synthesis is decreased, lipolysis is increased in the adipose tissue. Gut motility is decreased, gastric emptying is decreased, food intake is also decreased, is what you need to basically remember. So please be very sure what are all the actions. This is one simple table which will explain you everything, doctor. DASH diet, which is the typical diet which is being promoted to prevent the non-communicable diseases, that is hypertension and diabetes. It is rich in potassium, rich in calcium, rich in magnesium, the three important ions. Glucose 6-phosphatase deficiency typically lead to von Geit's disease. Gluconeogenesis is promoted by glucagon, inhibited by insulin. Please don't forget, doctor. अगर इंसुलिन खाएं तो नया ग्लूकोज की तैयारी नहीं होगा. क्यों? Because insulin will be there only when you eat a lot and lot of sugar is already there, then only insulin will come. Why will it cause new insulin get produced, new glucose to get produced? That's the reason gluconeogenesis inhibited by insulin, promoted by glucagon is what you have to basically remember. So insulin lead to glucagon secretion inhibited, lipolysis to get inhibited, right? Lipolysis to get inhibited, insulin. Insulin is a lipogenic hormone. It prevents lipolysis. It prevents lipolysis. Then it will also act on the hypothalamus. So whenever insulin is there, there is a decreased gluconeogenesis, decreased glycogenolysis. Because if the lipolysis is not happening, right, there are no free fatty acids. The reverse is true about glucagon. Glucagon promotes lipolysis, increase free fatty acid levels, increase gluconeogenesis and glycogenolysis. That is glucagon. But insulin is a lipogenic hormone. It inhibits the lipolysis. It increases, it prevents the free fatty acid release. It prevents the gluconeogenesis and glycogenolysis is what you have to basically remember. Good, doctor. Very good. Maza aa gaya. Now, dietary fibers, what is their effect? They reduce the intestinal transit time. That's the reason they are very good. They prevent colon cancer, etc. Where do you have GLUT receptors? GLUT4. GLUT4 is in skeletal muscle. Once more, doctor, GLUT1, most mammalian tissues, especially blood-brain barrier, brain, endothelial cells, glial cells, GLUT1. It has got a very medium Km value. What is Km value? Km value is Michaelis-Menten's constant. It is an indicator of the affinity for glucose, right? GLUT2 is there in liver and pancreas. It has a very high Km. GLUT3 is in neurons. It has a low Km. A low Km means higher affinity to take glucose. GLUT4 is there in fat, skeletal muscle, myocardium, and GLUT4 is the one which is sensitive to insulin. GLUT4 is sensitive to insulin. GLUT4 is sensitive to insulin. Please don't forget, doctor. GLUT5 is in intestine, brain, microglia. 5 is fructose. 5 is fructose. And GLUT7 is there in the liver, and it is for endoplasmic reticulum. So which lipoprotein is cardioprotective, doctor? HDL. HDL is cardioprotective. So ideally, your LDL cholesterol levels without any risk factors should be less than 100. With risk factors like diabetes should be less than 70. And your triglyceride levels must be less than 150. very important benchmarks. Reverse transcriptase is used in RNA amplification. So you should remember, whenever you want to amplify the RNA, first the reverse transcriptase will produce a primer. Then the RNA-dependent DNA polymerase typically will cause the formation of the circular DNA. RNA's activity will cause the removal of the primer, and DNA-dependent DNA polymerase activity ultimately will take over. So what are the various bases in human DNA, doctor? Adenine, guanine, cytosine, and thymine. Remember, cytosine, thymine are pyrimidines. Pyrimidines have only one. Pyramid is only one pyramid, no? Pyrimidine have only one ring. Purines have two rings. So you can remember, gap. Of course, P can be purine, P can be pyrimidine. Guanine and adenine. Right? So, U gap. Right? That is, purines are gap. That is, guanine and adenine are purines. Cytosine, thymine are pyrimidines. Adenine binds with thymine. Guanine binds with cytosine. Chargaff's rule. A 40-year-old man with the black pigmentation of the pinna and sclera typically has alkaptonuria. So this is the typical pigmentation which you need to remember, typically in case of excessive homogentisic acid, in case of the alkaptonuria. Nitrogenous wastes are excreted in the form of the urea, the whole purpose of the urea cycle. Synovial fluid has got hyaluronic acid. All the orthopedicians will give a lot of jari booty. Hyaluronic acid ले लो, आपका हड्डियों का ताकत बढ़ेगा, घुटनों में ताकत बढ़ेगा, कुछ भी नहीं बढ़ेगा. Only medical bill बढ़ेगा. Melanin, from where is it derived, doctor? It is derived from the tyrosine. So you should know that tyrosine converts into L-dopa by the action of tyrosinase. L-dopa typically become dopaquinone. Dopaquinone will form melanin. Right? So that is the story of tyrosine being the origin for melanin. 1 gram of protein yields 4 calories of energy. Please don't forget. Ammonia. What is the fate of ammonia in the brain? Ammonia is converted into glutamine. Glutamate converts into glutamine. Glutamate converts into glutamine. And in the process will capture the ammonia. Glutamate become glutamine in astrocyte. Glutamine will go into the neuron, and there the ammonia converts into NH4 plus. NH4 plus. NH4 plus is non-toxic. NH3 is toxic. Right, doctor? So that is the reason whenever you are having hyperammonemia, whenever there is any liver dysfunction is there, you have hyperammonemia. Lot of that ammonia, NH3, need to be converted into NH4 plus. For that, it requires a lot of glutamine to be consumed. For that, you require a lot of glutamate to get consumed. From where the glutamate originates, it originates from alpha-ketoglutarate. Alpha-ketoglutarate is required for the citric acid cycle to run. So that is the reason, doctor, whenever somebody has hyperammonemia, too much glutamine needed. For that, too much glutamate is consumed, and that lead to too much alpha-ketoglutarate consumed, and that will bring the citric acid cycle exhausted of the alpha-ketoglutarate. So it cannot cycle anymore. And the main source of energy to the brain is citric acid cycle. So that is the reason the brain will suffer the lack of energy and responsible for the hepatic encephalopathy is what you need to remember. So please don't forget, ammonia in the brain is converted into glutamine, originating from glutamate, originating from alpha ketoglutarate is what you have to remember. Now, doctor, what is the most abundant amino acid in the collagen? Glycine. Glycine is very small in size, and it is the most abundant amino acid in the collagen is what you need to remember. So what is the specific test for the uric acid? What is the specific test for uric acid in the gout? It is the synovial fluid uric acid levels is most specific, is what you have to remember. So doctor, that brings us to the end of today's wonderful evening. And please tell all your friends to come every day. Every teacher loves to have more and more number of students in the classroom. That makes the learning a great fun. And here we are sitting to make the learning a fun, preparation to the NEETPG a fun. And just for 999 rupees, we are going to hold your hand and give you the coaching by interacting with you every day, all the 1 year. Not only 1 year, more than that until you get the seat. And also be part of our WhatsApp study group. And every day I will release a lot of audio mantras, a simple question, and then an audio discussion of that in 1 minute. So like that, you are inspired by being in our WhatsApp study group. Good night and good luck. And once more, tomorrow we will all meet. Thank you.